Okay, for problem number 1, I see I have two congruent chords here and, here and here, which means then I have congruent arcs. So I know that this arc here has to be 140 as well. So if I take 360, subtract each of the two arcs I do know, 140 and 140, I'm left with 80 degrees. That arc is also the measure of the central angle. So number 1 is 80. Number 2, we know we have two tangents, which then makes this big triangle an isosceles triangle. It gives us that ATN is 72 degrees, which means this base angle is also 72 degrees. So now I can find my top angle by taking 180 minus 72 minus 72. That gives me 36. For number 3, this angle that you see here is an inscribed angle, which means the angle is half of the intercepted arc. So I need to take 164 and divide that by 2, which gives me 82. Number 4 says if our circumference is 120 pi, find the length of the radius. So we know circumference is 2 pi r. So 120 pi is equal to 2 times pi times my radius, and we're solving for our radius. So I can divide by 2 pi. Okay, so cancel out my pi's there. 120 divided by 2 is 60. So my radius is 60. The next one here, we have parallel lines. And remember, parallel lines cut congruent arcs. So if arc AE is C, this is also C. I know all the way around has to be 360. So if I take 360 minus 79 minus 153, I end up with 128. Divide by 2 and I get 64. So each of these two arcs measures 64 degrees. Oops, 64, there we go. Okay, number 6, this is an outside angle. We know outside angles are equal to 1/2 of the major arc minus the minor arc. So 70 is equal to 1/2 of x minus 61. So multiply both sides by 2 to clear my fraction. I have 140 equals x minus 61. Add 61 to both sides. I have 201 equals x. Okay, number 7 says find the arc length of arc CD if the radius is 18. So my radius is 18. If that angle is 40, the arc measure is 80 because it's an inscribed angle. So 80 out of 360 is my fraction, times 2 times pi times my radius, which is 18. Okay, so now you can just type that into your calculator, or you can do mental math, whichever you'd like to do, but you should get 8 pi. Again, you can leave your answer just in terms of pi. It says if the arc length is 8 pi, find the length of the radius. So arc length is 8 pi. Arc length comes from my fraction times circumference. So my fraction is 72 out of 360 times 2 pi r. All right, so first of all, I would cancel out my radii. So I have 8 equals, if I simplify this, I'm going to get 2/5 times my radius. I just typed it in my calculator, or you can do mental math again. Then I need to multiply both sides by 5/2. You should get the radius equals 20. Number 9. Okay, so for number 9, I see I have a linear pair here in the middle. So I know that this has to be 92 degrees. Okay, and that's an inside angle, which means that f plus 118 divided by 2 should equal 92 degrees. So f plus 118, if I multiply both sides by 2, I have 184. Subtract 118, f is 66. Okay, so this problem is just like the last one. We have an inside angle. So my angle is equal to, I need to add my two expressions together. So 14x plus 4 plus 20x plus 6, all divided by 2. Multiply both sides by 2, I'm going to have 146 equals 34x plus 10. Subtract 10 from both sides. I have 136 equals 34x. Divide both sides by 34, and I get x equals 4.
Okay, for this next problem, I'm going to just solve for a bunch of angles first, and then I'll go back and answer all the questions on the left. Reading the instructions, I can also see that arc HD is 50. So I'm going to go ahead and write that in. Okay, if HD is 50, then this inscribed angle up at B right here is 25. Then I'm also seeing this triangle EBD. So triangle EBD, I now have 2 of the 3 angles. So I can solve for this large obtuse angle at D here. So if I take 180 minus 38 minus 25, I get 117. And then I also have a linear pair there at D. And if I take 180 minus 117, I get 63. All right, I'm also seeing a small triangle up here by B. So right here, I have 2 of the 3 angles. Right, so if I take 180 minus 90 minus 25, I get 65. This vertical angle here is also 65 then. This small triangle down here at triangle CDF, I can solve for that missing angle. I know it has to be 52. Okay, I also see that C is an inscribed angle, right? So if I follow that out, follow it out to where it hits a circle, it intercepts this arc right here. So if angle C there is 52, this arc that I'm highlighting, that has to be twice that, or 104. So if that's a whole thing right here is 104, if this is 50, this has to be 54. All right, now BD there is an diameter. It's a diameter. I already know from HG to D, those 2 arcs there, those add up to be 104. So if I take 180 minus 104, I get 76. So this arc right here is 76. I have a right angle up here at B because it's a radius, and a tangent. Same thing on the other side, even though I don't have to mark it. So then, since this is a right angle, I know we've got 25 degrees. This has to be 65. I know here at this unnamed angle is another right angle, which means angle A out here is 25. Let's see here. Let's look at the arcs on the right side of the circle there. So we know that, let's look at arc CD. And there's more, I'm going to talk about this in a second, but there's more than one way to do a lot of these. So let's look at arc CD. So arc CD, right here, I can use this inside angle of 65. Okay, and then its other intercepted arc, if I follow out the legs, is going to be 76. So I know 76 plus x divided by 2 should be 65. So that was 76 plus my unknown CD divided by 2 will equal 65. Okay, so this is for arc CD. So I have 76 plus x equals 130. And then subtract subtract 76 and I get 54. All right, let's see if we have, or I could take 180 there minus 54 to get that last arc. 180 minus 54 gives me 126. Okay, now I just did all that. Keep in mind, I could have, that's a really bad 6. Looking at like an angle A, I could have used this outside angle, having this be my minor arc and this my major arc, right, and solve for any one of those 3. I could have, I didn't use my linear pair here, and maybe I'll need it in a second, but I could use linear pairs here. We have that outside angle. I used inside angles here. This here is an inscribed angle, this 63, so that's another way I could have gotten this 126. And then I could have used my semicircle, right? Take 126, or take 180, subtract 126 to get 54. Okay, so a lot of these, there's more than one way to get them. All right, so let's go through this. Number 11 says angle EBD. So EBD, that's 25. Angle ACE, we have labeled as 52. Arc GB is 76. Arc GBD, so this is the long way around. Remember, if it has three points, G to B to D, I need to go the long way around. So it's everything really except for this 104. So that gives me 256. Angle DBA is 90. Arc GD is 104. And angle DFC is 65. Okay, this next one, we have some tangents. So remember that tangents coming from outside the circle, from that same point, those are going to be congruent. So I do know S here should be 11. Okay, now, keep in mind we have that kite going, right? So I know, for instance, my radii are congruent, obviously, and these are congruent. But the diagonal that connects those vertex angles are bisect my angles. So like this has to be 35. I know a radius and a tangent form right angles. So just looking at the triangle AEO, I can find my missing angle here. So I know that has to be 55. This has to be 55. Then we have vertical angles here and here. So if this is 55 plus 55, that's 110. This has to be 110. All right, then looking at my triangle. Get my triangle here. I have 180 minus 110. That's going to leave 70 degrees. Divide that equally. I'm going to have 35 and 35. All right, so let's see. Angle P, there we know is 90. Angle Q is 55. R is 35. Okay, so the next one we have an inscribed angle. So since we have an inscribed angle, I know the angle, I need two of my angles to get one arc, right? So I would need 2 times, I would need 2 times my angle, which is 7x plus 16, to equal my arc, which is 15x plus 21. Distribute my 2, I have 14x plus 32 equals 15x plus 21. Subtract 14x from both sides, I get an x. Subtract 21, I get 11. So x here is equal to 11. Okay, but now I want to know the measure of angle Q. I want to know the measure of angle Q here. I really need to take 7 times 11 plus 16, or 76 plus 16, which is 93 degrees. Okay, here we have an outside angle that's made by 2 tangents. So if you remember, anytime we have 2 tangents, I want to be able to draw in my radii. I've got right angles here. Okay, so if that's my arc, that's also the measure of my central angle. And we know that those are supplementary. So 7x plus 19x minus 2 equals 180. So it's 26x minus 2 equals 180. Add 2 to both sides, I get 182. Divide by 26, and I get 7. I want to find the measure of angle B. So I need to take 7 times 7, which is 49. Number 24, I want the measure of arc HF. Okay, so this is an outside angle made by two secants. So I need to do my angle is equal to 1/2 of the major arc minus the minor arc. So my angle, which is 19x minus 1, is equal to 1/2 of my major arc is 69x plus 2 minus my minor arc, which is 33x. All right, so first thing I'm going to do 2 steps. I'm going to clear my fractions by multiplying by 2, and then I'm going to combine my like terms on the right side. So multiply by 2, and I have 38x minus 2 equals 69 minus 33 gives me 36x plus 2. If I subtract 36x, I have 2x. Add 2 to both sides, I have 4. So here x is going to equal to 2. Now I do want to find the measure of HF, right? So I need to take 33 times 2, which is 66. Similar to the last one, the angle equals the major arc, 1/2 of the major arc minus the minor arc. Okay, but now this one we're going to be careful, and I'll show you why. But my angle, which is x plus 55, is equal to 1/2 of my major arc is 155 minus my minor arc, which is x plus 45. Now I have to be careful because I got to subtract that whole expression. So really I'm going to have to distribute that negative to both terms here. So let's clean up a little bit. If I multiply both sides by 2, I have 2x plus 110 equals, this is really 155 minus x minus 45. So let's combine our like terms. I would have a negative x plus 110. Add x to both sides, I have 3x. Subtract 110 from both sides, I have 0, which is okay. Divide by 3, I get x equals 0. Okay, so now that's all I need to solve for in this one, just x equals 0. Okay, number 26. So this is a cyclic quadrilateral. So what you have to remember is that opposite angles are supplementary. Okay, so we're given that A is 100, B is 106. I want to know what's angle C. So again, opposite angles are supplementary. Right, so 180 minus 100 leaves me with 80. So angle C there is 80 degrees. So again, the same idea. This one just involves algebra. I do know that opposite angles here have to be supplementary. So 27x minus 18 plus 22x plus 2, that should equal 180 degrees. So let's combine our like terms. We have 49x minus 16 equals 180. Add 16 to both sides. 49x will equal 196. Divide by 49. X equals 4. All right, so identifying each statement as true and false. So number 28 says the degree measure of an arc is equal to half the measure of its central angle. Okay, so that's false because remember my central angle, whatever that is, defines what the arc measure is. What they're describing is an inscribed angle, so this is false. A chord is a segment connecting the center of a circle to any point on the circle. Okay, so this is false. What they're describing is actually a radius, right? A point on the center to any point on the circle. That's a radius. A chord, its endpoints are on the circle. Two circles are congruent if they have the same radius. That is true. So if two circles both have a radius of 3, oh, that's a bad circle there, but if they both have the radius of 3, then they are congruent. Two congruent chords in the same circle are equidistant from the center of the circle. So this is true. So if you remember, this is kind of what it looked like. So we said if the two chords are congruent, then those two pieces here are congruent. That is true. If a circle has a circumference of 10 pi, then an arc with a measure of 90 degrees has a length of 5 pi. All right, so this is arc length. So we're saying 90 out of 360, or 1/4, times circumference, which is 10 pi. Let's figure out what that is. So 1/4 times 10 pi. If I do that in my calculator, that's either 10/4 pi, or you can reduce that to 5/2. Nonetheless, that is 2.5 pi. Okay, and it says that the arc length should be 5 pi. Well, that's not true. So this would be false. Okay, so now these next several problems, you're going to be completing the square. So remember, you're going to rearrange first. Get my x's together, get my y's together, move my constant to the other side. So I have x squared plus 14x, leave a space, plus y squared plus 14y, leave a space, equals, you need to take this 49 to the other side, so it becomes negative 49. Okay, so we're going to complete the squares for the x's first. So this is where I'm taking 14, in my head, I'm doing 14 divided by 2, and I need to square that. So my b value divided by 2, that's 7. 7 squared is 49. I have to add 49 to both sides. Okay, so I'm going to go ahead and factor this while I'm here. So remember, we're just trying to take that trinomial into a binomial squared. So this is going to be x plus 7 squared. This inside part here, the 14 divided by 2, it's a positive 7. That's why it's a plus 7 here. Okay, so now let's do the y's. So in my head, I'm doing, again, 14 divided by 2, which is 7. Squaring it, that's 49. I have to add 49 to both sides. So now I have y plus 7 squared equals, clean up the right side, I have 49. So the center of my circle, remember it's always the opposite of my h and my k. So it's going to be -7, -7. And my radius is 7, because this is equal to r squared. So take your square root of both sides and you get 7. Okay, another completing the square. So I'm going to rearrange. I have x squared, no other x terms, which means I don't have to complete the square. That coordinate there is 0. They're not adding 0, they're not subtracting 0. We just don't have to write it. Okay, so plus y squared minus 16y, I'm going to leave my blank, equals, I would have to take 60 to the right, so it would become negative 60. Okay, so again, I don't have to complete the square for the x's because there's no other term there. So then, in my head, I'm doing negative 16 divided by 2, which is negative 8. Negative 8 squared is 64. I need to add 64 to both sides. Let me write that, just so you know. I did negative 16 divided by 2. Okay, so now when I go to write my parentheses, I'm going to have y minus 8 squared equals, now I have 4. Okay, so let's look at my center. My center lies at 0, positive 8, and my radius is equal to the square root of 4, which is 2. Okay, another one of these problems, I'm going to do the steps more thoroughly in number 33. So if I'm going too fast, go back to number 33. Okay, so rearranging, I have x squared minus 18x, leave a blank, plus y squared plus 2y, leave a blank, equals, moving that 66 to the other side, I get negative 66. All right, so negative 8 divided by 2 gives me negative 9. Negative 9 squared gives me 81. So add 81 to both sides. Now let's do our y's. Okay, so 2 divided by 2 is 1, 1 squared, so it's a positive 1. 1 squared gives me positive 1. Add a 1 to both sides. So negative 66 plus 81 plus 6 gives me 16. So my center here lies at 9, negative 1. My radius is a square root of 16, or 4. Okay, so next one, again, if you're struggling, if I'm going too fast, go back to number 33 and watch a video there. I explain all the details a little bit better. So rearranging, I have x squared minus 12x, leave a space, y squared plus 20y, leave a space, equals, taking my 8 to the other side becomes a positive 8. So negative 12 divided by 2 gives me negative 6. Need to square that. Negative 6 squared gives me 36. So adding 36 to both sides. Now my y's. 20 divided by 2 is a positive 10. 10 squared is 100. So combining my like terms on the right, I get 144. So looking at my center, I have 6, negative 10. And my radius is a square root of 144, or 12. Okay, the next one says the Ferris wheel has a diameter of 42 feet. How far will a rider travel during a 4-minute ride if the wheel rotates once every 20 seconds? Okay, so circumference, going around once, that's pi times diameter. So the circumference just going around one time is going to be 42 pi. Right, so this is one time around. Okay, now it says it goes around once every 20 seconds. That means every minute it's going to go around 3 times. Okay, so for 1 minute, I would have 42 pi times 3. All right, so in 1 minute, they go 126 pi. I think we're in feet, yep. Okay, but this ride is actually 4 minutes long, right? So I need to take 126 pi times 4 for 4 minutes. So 126 pi times 4 gives me 504 pi feet. You can leave it as that. If you type it into your calculator, you have 1,583.36 feet. Okay, the next one here we have matching. So sometimes maybe it's easier to work with the pictures backwards. I know A is a trapezoid. B is a kite. D over here is a square because I have the right angles at parallel sides and all 4 sides congruent. So D is my square. C here is a rhombus. All 4 sides are congruent, but we don't have right angles. That has to be a rhombus. Then that leaves E and F. So E has 4 congruent angles. That has to be a rectangle. And then F has to be my parallelogram. All right, so this is a Pythagorean theorem problem here. So we have a right triangle, and I know that because a tangent and a radius form a 90-degree angle. Okay, so that means that 5 squared plus x squared has to equal the whole hypotenuse squared, which is 9 squared. So if I subtract 5 squared from both sides, I have 9 squared minus 5 squared. So I'm going to type that into my calculator. Take the square root, I get 7.5. Solve for the length of the indicated arc. So this is arc length. So remember, that's a fraction of my circumference. So my fraction is 127 out of 360 times circumference. So 2 times pi times 7. Now, a lot of the ones you did for homework were pretty nice in terms of they simplified a lot bit better. This is not pretty. So I just typed this all into my calculator, and I had a 15.5. I even multiplied through by pi because that 127 over 360 times 2 times 7 wasn't pretty either. So it's just 15.5 millimeters in this case. Okay, so this one here, we have a bunch of terms again that we're just trying to match up. So I don't care if you look at your list first or your pictures first, but let's get started. So an obtuse angle has to be more than 90 degrees, so that has to be K. Vertical angles, that's C. Remember, they're the non-adjacent angles. I'm going to mark it off just so I know we've used it. Adjacent angles, well, I see a couple of sets of adjacent angles. I'm going to come back to that one. So perpendicular lines, that means two angles that intersect to form a right angle, so that's H. A linear pair, so two angles that form a line, that has to be B. Remember, they have to be adjacent and supplementary. Then we have supplementary angles, which means they just have to add to be 80. So if they just had to be 180, that could have been B or I, but because B is adjacent, that makes B a linear pair. I then is just going to be supplementary. Okay, angle BAC. A has to be my vertex, so that's D. The next one, ABC. B is in the middle, so that means B is my vertex, so that's answer E. Complementary angles mean two angles that add up to be 90. That's down here at G. My right angle is F. My acute angle here has to be J. I didn't cross off I. And then A is my only option left. Those are my adjacent angles. Okay, so as a reminder, no proofs on the exam, so you can skip 57, 58, 59. Number 60 I removed just because it's a little bit more challenging. Just again, trying to be fair with this whole situation. So number 61, I did give you the distance formula above number 60 because you are going to need it. I put the distance formula on the exam as well, so you will have access to that. Okay, so it says write an equation with a circle with a center of 2, -5, and a point on the circle 0, 1. Okay, so just visually, I'm saying that this point here is 2, -5, and there's some point on the circle. Again, this is not drawn to scale or accurately, but is 0, 1. So I know to write the equation of a circle is the quantity of x minus h squared plus y minus k squared equals my radius squared. So I need my center and I need my radius. Well, I know my center is at 2, -5. So I can do that part, but I want the opposite of h to be the opposite of +2 be -2. Plus y minus k, so I'd have y in the opposite of k be a +5 squared equals, I need to know the length of my radius. This is where the distance formula is going to come in. Okay, so the length of my radius is going to be equal to, I need to subtract my x's, so the square root of 0 minus 2 squared plus, subtract my y's, I'd have 1 minus a -5 squared. Radius equals 0 minus 2 squared gives me a -2 squared plus 1 minus a -5, that's really plus a positive, so that's quantity of 6 squared. So -2 squared, that quantity squared is 4 plus 36, so my radius is equal to the square root of 40. And I'm going to leave it like that because keep in mind, when we go to plug it in up here, I really want r squared. So what I'm really looking for is the square root of 40 squared. Well, the square root of 40 squared is 40. Okay, so the next set of problems are multiple choice. So I'm just going to walk through each of those. So for 62, it says HF is the bisector of angle EHG, which means these two angles are congruent. HE is congruent to HG. Which triangle congruency shortcut can be used? Well, I know HF is congruent to itself, so this is side angle side. All right, angle TUV and VUW are adjacent complementary angles. Okay, so adjacent complementary. We have right angle and they're next to each other, right? So we have TUV and I have VUW. If TUV is 80, then what's VUW? Again, you have to know it's 90, so 90 minus 80 is 10. In the figure below, if AXC is 10x, then angle BXD would also have to be 10x because those are vertical angles. Find the value of x. So we just talked about how vertical angles are congruent. So I'd have 3x equals x plus 28. Subtract an x from both sides. I have x equals 28. Divided by 2, I get x equals 14. Right here, if we have parallel lines, then the angles that are highlighted here, these are corresponding angles, which means my angles are congruent. So 2x plus 5 has to equal x plus 12. Subtract an x from both sides, we get x. Subtract 5 from both sides, we get 7. Two lengths of the sides of triangles are 4 and 7. Give all possible lengths for the third side. Okay, so this is where we said when you have the three sides of the triangle, two sides always have to add up to be greater than the third. Okay, so this is where we said, okay, there's a high end and there's a low end. So if I take 7 minus 4, that's going to be my low end if I subtract them. To get my high end, I would need to add them. Okay, so we have 3 is less than or equal, or less than x, which is less than 11. Okay, now it says find the possible lengths for the third side if the lengths of the sides are all integers, meaning no decimals. So it can't be 3, right? It can't be 3, and it can't be 3.1 because that's not an integer. So the next integer in this interval here is going to be 4, and then it would go 5, 6, 7, 8, 9, 10. Cannot include 11 because x has to be less than 11. So our answer here is D. All right, given that OH is congruent to JH, okay, so we're talking about this side and this side are congruent. And O is congruent to J. And notice we have a right angle there, which congruent to shortcut says that the big triangle GHJ is congruent to HMO. Okay, so let's just draw out GHJ, and we can mark what we have here. So I see I have a right angle. Here's GHJ. Okay, I've marked this angle here, and I also marked side HJ. So here I have angle, side, angle. All right, number 69. Given that JL, so we got a big side, and LN are congruent. KL is congruent to, so just this little piece, LM. Okay, so the other thing I notice here, these are overlapping triangles. They share this angle here. So let's just draw out just one of those. There's JLM. Okay, so I marked all of JL in red. All right, so that part. Then I marked LM in blue. And then I said L has to be congruent to itself. So that is a side angle side. Number 70 says the sails of two boats are pictured below. What is the value of Y? Okay, so these two triangles are going to be congruent because of HL, right? We have hypotenuse leg because we have right triangles. So that means then this has to be Y degrees, and if this is 20, this has to be 20. Okay, so then I can just use my triangles. So if X is 20, that makes Y 70. All right, 71. If the measure of WYX is 35 degrees, then what is the measure of XZY? I want to know this angle right here. Okay, so first of all, let's point out that we have two overlapping triangles here, right? So there's one and here's one. So we know that the triangles are congruent. So if this angle is 35 and I have a 90-degree angle, looking at this blue triangle, that makes angle W here 50, oops, sorry, wrong pen, 55 degrees. Okay, well, W and Z are going to be congruent angles because my triangles are congruent. So my answer is B again. All right, if triangle ABC is congruent to triangle XYZ, AB is 3, BC is 6, AC is 4, what's the length of XZ? Okay, so remember those congruency statements, they're made so that you can match up the letters, right? XZ is the first and the third letter. I need to match it to the first and the third letter in this triangle. So AC and XZ, they're going to be congruent. So AC in my list here is 4, so XZ has to be 4. All right, so we have some angle puzzles here to work on. So for number 1 here, first of all, these 3 angle puzzles, is important to notice that these are not drawn to scale. Okay, so even if it says it's a 90-degree angle and it doesn't look like it, it is what it is. Okay, so take it for its worth. So I'm just going to start finding some angles, and then I'll mark those, and then I'll go back and try to answer questions if I can. All right, so I see I have a vertical angle here in the middle at N, so this is 80. I should probably read the directions. M and N are sensors. A, N, and C, N are tangents. The smaller circles. Okay, so if they're tangents, that means I'm going to have right angles here. If there's angle 5, then it has to be 90. AB is congruent to CD. So AB is congruent to CD. Okay, so actually we've created a kite because I know my radii are congruent here. And they're telling us that those segments are congruent, so then these also have to be congruent because they're radii. So we created one big kite there. Find the missing angle measures. Okay, so if I know those 2 angles we started with are 80, keep in mind these are isosceles triangles in here. So my base angles have to be congruent. So 180 minus 80 gives me 100. 100 divided by 2 gives me 50 and 50. There's angle 4. Same thing's going to happen in that other triangle with that bow tie. I'm going to have 50 and 50 here. So there's that. The skinny triangle with angle 2, we have a base angle of 65. This base angle has to be 65. So then, let's see, that's 130. That makes angle 2 50. All right, then we need to go for angle 1. All right, so I think what I'm going to do actually is draw in another radius. There's probably more than one way to do this. I'm going to draw in another radius so I can create 2 isosceles triangles. Okay, so I know this base angle has to be 50, so I know this is 80. That's a terrible 80, but that is 80. I can solve for that large obtuse angle at M, again because of that kite. So I know M has to be 180 minus 50 gives me 130. So now I can find that vertex angle. I can find that central angle that I don't have because all the way around M is 360 degrees. So if I take 360, subtract 130, and subtract 80, I have 150 degrees. So this angle right here is 150 degrees. So if that's 150, my 2 base angles have to be the same. So I have to split up 30. So this is going to be 15 and 15. So there's angle 1, it's 15. Okay, angle puzzle number 2, I want you to skip. The reason is there's an error in this, and I didn't catch it in time. Angle 1 ends up being, has like 2 different values it can be because they gave you too much information and they gave you wrong information. So I apologize, just skip this one. Okay, so angle puzzle number 3, this one's tough. Okay, this one is very tough, and the picture again is not drawn to scale, which is super important because there's some bad ones in here. I did not include the blanks 1, 2, 3, 4, 5, and so on, just because I needed the picture to be larger. All right, so A is the center of both circles. BC is the diameter of the smaller circle. Find the indicated angle measures. Okay, so I'm going to start with that small circle. I see if 140 degrees, I'm going to use my linear pair. I know this has to be 40, which makes this arc 40. Don't know if I need it yet. We'll go there. Okay, now, a lot of times what happens with these problems is people do get so overwhelmed, they can't do anything. Okay, so what I try to look for are, I try to follow a pattern. So I try to go through and look for any inscribed angles. Okay, whether I can do anything with them or not, I just try to find inscribed angles. So for instance, angle C here is an inscribed angle. Can't do anything with it. 7 is an inscribed angle because this vertex is on the center. Well, I noticed that opens up to a diameter. So that means angle 7 has to be a right angle. Okay, now angle B is an inscribed angle. Don't have quite enough for that. Let's go out to the big triangle, or the big circle. So here we have three inscribed angles. So let's look at this one. I have 40 degrees. Follow that out. That means that arc is 80. Okay, then I do notice I have another, well, let me come back to that. So I have this inscribed angle, which doesn't really lead anywhere because I don't have a complete chord. Same issue here, this inscribed angle. Don't quite know enough yet because I don't have all parts. 9, its vertex is there, but again, the legs don't go all the way through. Again, here, legs don't go all the way through. Angle 2 is an inscribed angle. Ooh, it opens up to that 80-degree arc, which means angle 2 has to be half of that, or 40 degrees. Okay, now that 75-degree angle, follow its legs out. Follow its legs out. This arc here has to be double that. So this arc, here to here, has to be double that. That's 150. Okay. Let's see what else. Oh, this angle here is not named, but it has, let me get both arrows. It's also opening up to 150, which means this angle must also be 75. All right, so let's see. I did all the inscribed angles, I think. Let's look at, oh, no, I didn't do all my inscribed angles yet. Let's go back to this little circle. I have this 31 degrees, right? So if I follow its legs out, that arc has to be 62 degrees. Okay, now notice that I have a radius and a chord intersecting, and they form a right angle, which means this chord is bisected. Remember, so this actually creates that isosceles triangle. So I know this has to be 31. That inscribed angle would make this arc 62. I have a right angle right here. So now I can solve for angle 1 by just using my triangle. So 180 minus 90 minus 31 gives me 59 for angle 1. Which means this whole big angle on the other side would be 59, but I don't know enough quite yet to do anything with that. All right, so I did, let's see, what did we do? We did inscribed angles. So what about central angles? So central angles, a lot of messy arcs in the middle. If I look at the big one, I have this central angle here. Oops. This central angle right here, right, opens up to this 150-degree arc, which means my central angle here has to be half of that, or 75. Okay, well, no, I'm sorry. Yeah, this has to be 50. I'm sorry, 150. I don't know why I said 75. This has to be 150. Well, I already know this part's 40, so this part has to be 110. All right. Then I can solve for angle 6 because I got a linear pair. So angle 6 there is 70. I know I have a right angle right here. So if we look at this big triangle right here, I have two of my three angles. So I know this little unnamed one here has to be 20. Another thing I see, and again, this is another one of those where there may be more than one way to do this. I see a big quadrilateral right here. Okay, so if I take 360, subtract what I know, I'll have this angle left. So if I take 360, I want to subtract 140, 90, 75. That leaves 55 for all of this. Okay, and I already know this part's 40, which makes this part then 15. And then angle 9, notice is congruent, so that has to be 15. What else do we have? Okay, angle 8 is an inscribed angle. So what I did notice here, if this whole thing is 150, right, angle 8 opens up to the rest of that circle I did not just highlight. So if I take 360, subtract 150, I'm going to have this big arc. So 360 minus 150 gives me 210. So angle 8 is an inscribed angle that opens up to an arc of 210. So I can take and subtract, or I'm sorry, divide that by 2. So 210 divided by 2 gives me 105. So angle 8 here has to equal 105. All right, so I think I've taken care of inscribed angles and central angles again. Then I start looking for triangles. If I'm stuck, I'm just going to start looking for triangles. Okay, so I have, here's a big triangle. I just saw that one. So that's 180 minus 75 minus 40. Gives me 65. That means this angle is 65. My vertical angle here is 65, which I could have also just worked with this smaller triangle here, right, and gotten my 65 and then did my vertical angle again. Let's see, do I have everything yet? Oh, I still need angle 5 down at the bottom. And then I think I have everything. Okay, so angle 5 down at the bottom. I can see it's part of this. Oops. It is part of this quadrilateral right here. Okay, so again, 360 degrees. So if I take 360, subtract 105, 15, and 150. I'm left with 90 degrees. So angle 5 is 90 degrees. Okay, so again, this is one, like, it is not drawn to scale, which sometimes makes it harder, but try to follow your all of your rules. So let's see, I have angle 1. I just want to double check. Angle 1 is found, 2, where's 3, 4, we just did 5, 6 we have, 7 is 90, good, 8 we just did is 105, and then 9 is 15. Okay, so that's all of our angles.